Today we are going to deal with chapter acids, bases and salts. The objective of doing this chapter is to know the differences between acids and bases, to discuss the importance of studying acids and bases, and to perform the experiments which are dealing with acids and bases. To start with, let us take examples of some common substances which contain acids. All of you come across in your daily lives around some substances such as lemon juice, which contains citric acid, similarly vinegar, which contains acetic acid, and the most common, which is very common and which all of you know, is the carbonic acid, which you find in all aerated drinks. This shows the need of acids in our day-to-day lives. Without vinegar, you are not able to preserve things. Aerated drinks are very common in summers as they give us a soothing effect. Similarly, lemon has a role to play in our day-to-day being. So the importance of acids is remarkable. When we talk of acids, the very first thing which we come across is the sour taste which acids possess. So one of the property of acids is sour taste. Acids are sour in taste. The other properties basically include the identification of acids, and acids are identified by using indicators. Now the question comes here, what do we mean by indicators? Indicators are the substances which help us to identify the nature of a substance. When we say the nature of a substance, it meant that whether a given substance is acidic or basic in nature. The commonly used indicators are litmus, which is a natural indicator, extract of China rose, which is a natural indicator again, and phenolphthalein, which is actually a synthetic indicator. When we talk of acids, acids turn blue litmus red. Litmus is an indicator which is available to us in two forms. One form is paper and the other form is solution. When acids come in contact with litmus, they turn blue litmus red, and when we say that synthetic indicator like phenolphthalein comes in contact with acids, it remains colorless. So indicators are actually used to identify whether a given substance is acid, base or base. Now before we continue, an important thing to understand here is whenever we are talking about acids, we should try to find out the acids which we come across in our day-to-day lives, in the food products which we consume, and similarly we should also know that what importance acids have in our daily lives. When we talk of acids, acids are important chemicals which are used in labs to find out the different reactions which are taking place around us. Formation of gases is only possible when metals generally react with acids. Formation of gases, when I say specifically, we refer to gases like hydrogen, carbon dioxide, if they have to be prepared synthetically, that is artificially in the lab. Similarly, bases have their own importance in our day-to-day lives. Bases are the substances which actually are bitter in taste, if we talk in terms of taste. If we talk in terms of ionization, bases are the substances which yield hydroxyl ions in solution. And if we talk of acids in terms of ionization, acids are the substances which yield hydrogen ion in solution. So this gives us the major difference between acid and base, that the acids in solution yield hydrogen ions and bases yield hydroxyl ions. Second difference is in terms of taste. Acids are sour in taste, bases are bitter in taste. Acids turn blue litmus red, base is turn, red litmus, blue. So these are some of the major differences between acids and bases. Now next we'll come to the characteristics of acids, a recap. Acids can be characterized by sour taste, blue litmus paper red. We find acids in drinks, and one of the example given here is of lemon juice. Next comes characteristics of bases. A base is characterized by bitter taste. Example of base is milk of magnesia. Other examples of bases are bases found in soap, that is in the form of sodium hydroxide and potassium hydroxide. Sodium hydroxide, which you call as caustic soda, potassium hydroxide, which you call as caustic potash. Bases are slippery to touch, soapy to touch. Bases turn, red litmus, blue. So these are some of the characteristics of acids and bases. If we talk of acids and bases, here we also come across the important product which is formed by combination of acid and bases, and that is salts. Acid reacts with bases to form salt in water, and this important reaction is called as neutralization. When we say this important reaction is called as neutralization, now the question comes how this reaction happens. How it happens? Actually, the hydrogen ion of acid combined with hydroxyl ion of base to form water, and along with it we have production of salt. Now this neutralization reaction is also called as titration reaction. Now question comes here when we talk of acid, bases and salts. An important application of acids is seen when we add vinegar to baking soda. Baking soda is sodium hydrogen carbonate or sodium bicarbonate. When both of them react with each other, they result in production of a gas which turns lime water milky, and this gas is called as carbon dioxide. So when we say baking soda reacts with acid, vinegar, it results in production of, I am writing down the formulas though you may only give the word equations. It results in formation of salt, and along with it we have formation of carbon dioxide. The salt which is formed here is actually acetate. Now you don't need to go in such deep details, you only need to remember vinegar react with acid to form salt and carbon dioxide. Now here the important thing which we would like to highlight is that how will we test for carbon dioxide? We will test for carbon dioxide by passing the gas through lime water. Lime water turns milky, and this indicates that when lime water is turned milky, the gas formed is carbon dioxide. When we talk of neutralization reaction, salt formation, another reaction which is important here is reaction of sodium hydroxide with hydrochloric acid. It results in formation of common salt which you use in your daily lives. Now question comes here, how are the neutralization reactions important? Neutralization reactions are important as they result in formation of different areas where we need to do detection. For example, if you know that we all know that soils are, different types of soils are required for different types of crops. So if we know the nature of soil, we can easily identify which crops will grow well in which type of soil. For example, some crops grow well in acidic soil, some crops grow well in basic soils, then there are some crops for which neutral soils are required. So by knowing that what is the nature of soil, we can easily tell what type of crops may be grown in that specific type of soil. Another important application or use of neutralization is when we suffer from severe acidity. At that time, doctors advise us to consume antacid tablets, which basically contain base, so that they neutralize the excess acid produced in stomach and relieves us from excess acidity and thus relieving us from indigestion. So that is the important use of neutralization in our day-to-day lives. So now you can easily understand how important are acids and bases in our day-to-day